Okay, Larry, W6WUH in California. Let's take a quick look at the things that you need to know if you get a Gonset Commander and want to hook it up and test it or put it on the air. The first thing is that there are 4 capacitors that you really need to replace with modern units. This 3-section electrolytic here, you can see on the schematic, is 3 parts. One is this one, a 20 microfarad to 25 volt cathode bypass for the 12AT7 low level audio stage. There's a 15 microfarad 450 capacitor, which is basically a voltage regulating and hash filtering capacitor, probably meant to compensate for the inadequacies of cheap power supplies like a vibrator supply that might have been used to power this. So this will eliminate hash here in the plate circuit of this low-level audio stage and keep that from being amplified and becoming part of the modulation. And it also adds some reserve capacity to help regulate the voltage as the modulator peaks tend to drop the voltage down. This added filter capacity helps to stabilize that voltage. And the third is this one, which is 10 microfarads at 150 volts, which is the cathode bypass for the push-pull 7C5 modulator tubes. So blue wire, red wire, yellow wire, all coming up here to this filter cap, and that's where they go. Next thing is this high-cut capacitor that goes across the output, the secondary of the modulator transformer. Basically goes to ground off of pin 4, and I think this cuts high frequencies. This says 0.007 microfarad, and there's no voltage rating on the cap, but it's listed as a if you read the capacitor, as a vibrator buffer capacitor, and those typically have a voltage rating of about 1,000 volts. So, like the paper caps you'd find in an old oscilloscope, rated at 1,000 or 1,200 volts, this is a paper capacitor that's definitely suspect, and clearly, if it shorts out, it's going to short the high B plus to ground and possibly draw a lot of current through the secondary of the modulation transformer and blow it up. So, you want to get something like one of these, 1 kV rated, that's a 0.007 at 1 kV. The other one, very close to 0.007. That one happens to be rated 4 kV. And I think either one of those is a suitable replacement. I think if the value is within 20%, you're going to be fine. This resistor here shows up in the schematic as R11. Now the notes on the schematic say change to 25K 10 watt if you're going to use 425 to 450 volts as the B plus. This one is 30K, and it's clearly not original. You can tell from the soldering that somebody's put this in here. So maybe the next closest value they had, and they intended to run it on 500 volts of B plus or something. I would suggest very highly not using a high B plus any more than 450 volts. Figure that the peak voltage in the modulation transformer is going to be double that, which is 900 volts. There's no marking on this modulation transformer. We don't know who made it or what its ratings are. You figure it's probably about a 15 watt modulation transformer. But I think 450 volts of B plus is the highest that the Gonset mentions, and I think it's prudent. for this thing to not to use 500 or 600 volts as I suggested in another video, but keep it to 450 at the most for the high B plus, and the low B plus has to be kept at 300. The max voltage rating for the golly, I don't even know what the max voltage rating is for the 12AT7. So anyway, 300 volts I think is smart. Let's look at the pinouts for the power connector. If you don't have access to a schematic, or you just don't know, here they are. Freeze them and print them. Pin number 1 and number 2 are the cathodes for the oscillator and the final amplifier tubes. You've got to ground those pins to operate it. They may have brought those out to the rear panel so that you could key them for CW. That's the only real reason I can think of. Pin number 3 is the hot side of the filaments. Check your wiring and see if you're wired for 12 volts or 6 volts. It's in the schematic. There's the alternate wiring for 12 volts, where they've got two 6-volt sections in series. If you add up the filament current for the two different groups, they're both 1.55 amps when you add them up, and they put those two things in series and fed it with 12 volts so the voltage will divide evenly. Okay, pin 3 is the hot side of the filaments. Number 4 is ground. That's your B minus and your return side of your filaments. Number 5 is high B plus. Remember, they've got the B plus for the modulator and the final amplifier split off from the oscillator and the low-level audio stages. So, for the high B plus, number 5, that can be anywhere from 300 to 450 volts. But remember, as in all of these small AM transmitters, mobile transmitters, you always have to change the screen resistor or jumpers, series of screen resistors to set it up suitably for the B plus that you're running on the final. So in this case, I don't know what the value was supposed to be with 300 volts on the plate. I've got to try to find out. But they're telling you if you're going to run 425, 450, to use 25K for this value. So there we go. As much as I can tell you right now. Low B plus, not over 300, 315 volts. I'd say keep it to 300. Number 7, pin number 7 on the rear connector. It's a push-to-talk line. This is just straight from the microphone through the mic jack. Goes to ground when you key the mic jack. So you can control anything you want with power supply relays, antenna relays, or both. Pin number 8 is the same as number 4. We looked at that before. They're both, oops, my shadow's in the way. They're both tied together and they both go to ground. So you can use 4 and 8 interchangeably as a ground. Pin number 9 and 10 have no function in the radio. There's just 2 wires that run from a front panel switch and come back to terminals on the back connector so that you can turn something external on and off. So let's see, what else do we need to know? Well, we talked about this filaments. Just take a look at it. Right here. Here we go. The oscillator tube 6AG7, filament current 0.65, 6146, 1.25 amps. Add them together and you get what? 1.9, let me see. No, you get 1.55 amps. And the two 7C5s are 0.45 apiece. Put those together, that's 0.9. And the 12AT7, what do we got? I've got it added up wrong. It's the 6146 and the 12AT7 are joined together. That's 1.55 amps. And the two 7C5s and the 6AG7 go together. That's also 1.55 amps. So you string those two things in series, feed it with 12 volts, and the voltage divides equally between the two groups, and that's how you convert it to 12 volts. And in this case, these white wires are the jumpers that have been changed around to connect it to 12 volts. So the filament wires are the black and white wires in there. Okay, I think that's pretty much it on my radio. Let me put this down for a second. On the schematic, on the back of the radio, you can see there's two ways to feed an antenna. One with this balanced line and one with the coax feed. If you look at the schematic, it shows you that one of the two balanced line things is actually supposed to be a tap on this coil. Well, that tap doesn't exist, and if you look in here, you see that there's no connection. So don't assume that you're going to be able to feed a balanced line with this thing from your radio the way it is. And if you fed that against ground, it wouldn't be any different than feeding it with the coaxial connector. So at least in my radio and in my plug-in coil, there is no tap on this coil. So that's, what can I tell you? So I think that's the things that you need to know: the voltages, the pinouts, the capacitors you need to change. There is no antenna loading control. If in the Gonset supplied coil, these yellow wires are the antenna coil, and you can change the loading by moving these positions on the coil. This coil is a bud coil that I'm using for 40 and 80, and the inductive link is glued there. It's not movable. It's probably possible to take a small capacitor from the hot side to ground and tune that link and maybe get better loading, but you can do the same thing with any of the little tiny tuners that fit in your palm of your hand, like the cheapest little MFJ thing. I might try that on the bench to see if it makes any difference, but my guess is it's not going to be a whale of a big difference if you're loading into a fairly non-reactive 50 ohm load. If you're loading into something that's really goofy, then I think the assumption was that you would use some kind of external matching device. Back in the day when they made these transmitters, people had roller inductive coils and switchable capacitors and quite a few little tricks that they did to affect base matching to their mobile antennas. So the assumption was, when you made a transmitter like this, that kind of matching was going to be done basically in the trunk of the car and wasn't going to be part of the transmitter, because there was such a wide range of possibilities, and often the antennas were presented a very low impedance load. It was probably not too practical to build into the transmitter. So I think that's the story for now. Those are the things you need to know. But really, seriously, don't use more than 450 volts of B+. I don't think the thing was designed to stand it. It really is pretty much dependent on the modulation transformer, but I think at 450 the peaks are going to take it to 900 volts, and that's asking a lot of this small transformer. W6WUH, thanks for looking.